Okay, in this video, I'll talk about a very simple process which you guys must have seen. If you have been observant enough, you must have seen it everywhere, like on a daily basis, you must have seen. I'm talking about diffusion. Diffusion is a process that you will not only see in your surrounding, but it is also one of the processes by which molecules move from inside of a cell to the outside or from outside of a cell to the inside. Diffusion is a very basic process, okay, very simple, and it is something that you see in fluids only. Fluids as in only in gases and liquids. You will not find the process of diffusion being shown by something that is solid. So these two states of matter are good ways of demonstrating diffusion. So diffusion here is described as the movement of molecules. So if these are molecules over here, and over here the molecules are very crowded, a lot of molecules, yellow molecules. Diffusion is the process by which molecules move from a region of their higher concentration to a region of their lower concentration, right? So this region, the molecules are highly concentrated. So this is the region of higher concentration, and the molecules will spread out from there to anywhere that its concentration is lesser than what it is over here. So it would spread out mainly. So even if there are a few yellow molecules over here in this part of space, the molecules will still move from a region of their higher concentration to a region of their lower concentration or no concentration at all, right? So the flow is described as a flow that happens down the concentration gradient. So this concentration from high to low, so it follows a certain gradient. It will always go down the concentration gradient from high to low until until there comes a point when the particles are roughly equally distributed or fairly spread out. That point is referred to as equilibrium. So we say that the process has reached equilibrium. At equilibrium, these molecules, which were highly concentrated over here, at equilibrium, so after a while, over here, after a while, these molecules, these yellow molecules will be quite spread out. Same number, but quite spread out, right? So in any given space, you'll find out there is almost an equal distribution, equal number of particles. So that is the point where equilibrium has been achieved. But even in equilibrium, you must understand that it's not like this equilibrium is static. This equilibrium is not static. This equilibrium is dynamic. Dynamic equilibrium. So that means the particles still move, whether it's in a liquid or whether it's in a gas, the particles will still move back and forth. The particles will still have a tendency to move back and forth. That is, from the region where they moved to the region that they have ended up being, they will still move from that region to the other, but equilibrium will be maintained. Okay, so that is what diffusion is. Now, some of the examples of diffusion, let's say if this is your room and you're getting ready to go out somewhere and you spray, you're getting ready. So this is, let's say, the mirror, and you spray some perfume before you go out. Now, when you spray the perfume, here you have, you're standing, you're getting ready, yeah, and this perfume bottle that you have used, and please use the perfume bottle. Okay, so this is your perfume bottle, and you have sprayed it. So the perfume molecules are highly concentrated in this part of the room. So if I use blue to imply that these are the perfume molecules, these perfume molecules are pretty concentrated in this part of the room. So because this is the region of higher concentration and the rest of the room, as you can see, there are no perfume molecules. So the perfume molecules will start moving down their concentration gradient. That is from the region of higher concentration to the region of lower concentration until equilibrium. Which is why when you go out and you spray your perfume and you're ready to leave, after a while you'll find out that the entire room will be filled with the fragrance of the perfume. Or let's say you are sitting in your room and you're studying over here. Let's say you're studying over here, and you didn't know that your favorite dish is being prepared. Okay, so you're studying over here. This is your chair, you're studying, and you find out that okay, your favorite food is being prepared, and the kitchen is far away. So this is your kitchen, and the food was being prepared, and you can tell that it's your favorite food because the molecules which make up the aroma of the food, the beautiful, uh, delicious food which is being prepared, those molecules move from a region of their higher concentration, which is the kitchen, the cooking vessel in which it is being prepared, and it diffuses out. It moves down the concentration gradient. So as the food is being prepared, more molecules of that food are accumulating here and they are moving down their concentration gradient. And when it reaches you, you take a whiff of that, and those molecules enter through your nose, and you can tell that, oh, your favorite food is being prepared, right? Or something very simple like you have a glass of water, let's say you paint. Those of you who paint watercolors, you would understand what I'm saying. So you have a glass of clear water, and you normally use this water to wash your brush, right? Whichever paint you're using. So you keep washing your brushes, right? When you paint using watercolor. So when you do that, you'll find out that whichever paint this brush, the mop brush had, the paint will dissolve in the water, and the clear water will slowly take up the hint, the hue of the color, right? But initially, when you dip the brush, the paint is pretty concentrated where you dip it. If you if you do the experiment, you'll find out that a drop of paint, if you let it be, you don't disturb the glass, and that drop of paint will slowly diffuse out. Let's say it's orange paint. I'll use the color orange here. So this is orange, a drop of paint you've dropped here, and it will take some time. If you don't disturb the glass of water, even then it will slowly spread out, and the pigment will fade out, but it will slowly spread out, and the glass of water will no longer be as clear as it was earlier. It's because when you dropped this orange paint, so initially over here, let's say this is where you dropped, and the entire glass of water was filled with clear water. So these are the water molecules, imagine, like over here, only and only water molecules, and you dropped a little bit of paint, just a drop of paint. So over here, the paint molecules are highly concentrated, right? Now the paint molecules move from their region of higher concentration to their region of lower concentration. But the water molecules also move from their region of higher concentration to their region of lower concentration, which is the area, the volume, the space which is occupied by the paint molecules. So in that space, there are lesser water molecules. So that means the water molecules also travel from a region of higher concentration to lower concentration. So that is diffusion. So diffusion is not only movement of one type of molecule. Like this example of spraying the perfume that I used, the perfume molecules are spreading out. Right, over here the perfume molecules I said are spreading out. But you must also know that the molecules which make up the air around you, the air that you inhale, the air that you exhale into, the molecules which are invisible to you, those molecules are also rushing from their region of higher concentration to their region of lower concentration, which is the region where you have just sprayed the perfume molecules into in the air. Okay, so diffusion is that. Okay, it is the movement of both kinds of molecules. Any molecule, it is from their region, their region of higher concentration. It is the molecule that is diffusing out. It is that molecule's region of higher concentration that it will move from to its region of lower concentration until equilibrium is reached. Okay, I hope these examples help clarify the, the process of diffusion, the concept of diffusion, and I'll soon come up with other videos on discussions about other processes via which the molecules move from inside of the cell to the outside, like even like diffusion, passive diffusion, facilitated diffusion, then osmosis, active transport. We'll talk about all that. Until then, I hope you liked it, and thank you for watching.